In today's session, I'm going to talk about all important keywords, definitions required to prepare your data model. This is called basically semantic data modeling in Cognos. So in the last session, I quickly walked through about the whole lifecycle implementation, and you see once you plan and manage your underlying infrastructure and resources in order to implement Cognos as your solution, the BI solution, the next step is to prepare your data model. It is called semantic data modeling, and semantic data modeling is done through framework manager. That is step number third. Once your model is ready, people are ready to design report and authorize report and distribute to the respective channel. And finally, your business users are going to consume the information via report. So this is a whole life cycle implementation. We are going to follow the same life cycle implementation in our learning. Today we are going to start with design and data modeling through framework manager, and subsequently we see how to prepare different kind of report, and we'll take some couple of example of how reports are basically accessed by your business users. So let's be very focused about designing framework manager now. You see, framework manager workflow starts from some underlying data sources. Framework manager is a data modeling tool. It's a graphical presentation of your metadata, including your dimension, member, and fact. When I say graphical presentation, when you look at when you visualize your information, this is how it look like. So you have a couple of dimension and facts. We graphically organize them in a certain manner. You can call them as a data model, where you have all information about facts, dimension, keys, join, constraint, column, all information you can see over here. That's a graphical presentation of it. So the step first, in order to prepare your framework manager, you design and create report. Step second, prepare metadata. As I discussed in the previous session, your metadata depends upon the metadata, and data dictionary is actually provided by your data modeler, where you have all information about your metadata, including your connection name, database join, tables, keys, column, constraint, column type, joins, all the information required to process your query. Your metadata contain that. In a large enterprise data warehousing, there are multiple tables, there are multiple dimension and facts. It is difficult to understand and identify what dimension and fact contain the right piece of information to prepare your report. So metadata dictionary give you all required information. For example, you would like to fetch data from employee details. Employee detail may be exist in multiple tables. Which is the right appropriate dimension and fact? So metadata information give it to you. This is a Bible for us, a baseline document which is required to prepare your Cognos report and framework manager. Then prepare a business view. The business view, there are two parameters we need to, when you're working as a business intelligence report developer, we also have to ensure that two important things. First, my final consumers are who? Final consumers are two category of users. One is your business analyst. They are smarter people and they know how to use system and they have good knowledge about business data. So primarily they play around with the reports. You call this, they do ad hoc reporting, or they also do self-service report. Right? Often the business analysts are many in an organization, and then second, consumers are view-only users like C-band people. C-band CEO, CFO, they are often view-only user. They are not rigid definition, but often they do not have time to play around the data, but they like to see the summary information about the business. So they want one static view of the business day to day in very highly summarized manner. We often offer them a dashboard. Dashboard is exactly like your car dashboard, where you can see all the control panel in a common window. You can control the entire car through a common dashboard. So couple of questions we ask before we start designing a solution. The first question we ask, your user profiles. What kind of users are there? Okay. They are business analysts, right? They are maybe business analysts, they may be financial controller, maybe budget administrator. There are multiple profiles. There are product manager, promotional manager, like this. There may be many profiles. So what is the customer profile? Number of users. How many people are going to access my solution? Number of base users. So we assume my solution is going to be used by 1,000 people, and number of concurrent user. Maybe you have 1,000 user, but at one time only 100 user may be accessed in your peak business hours. We assume our peak business hours are peak business days or hours. We assume most often it is month closing period or opening period. We got more queries. Couple of basic question has to be answered. I have a list of questionnaires which I give it to the user, your business user, and we ask them to provide us some input about it. When you prepare a business view in one word, business view as the name indicate, it's converting your metadata into business vocabulary. Why we need to convert this now? Imagine if I ask one of my user to query data from this table, TBL product V107. It's pretty complicated. There are a lot of abbreviation, special keywords are used. Rather, if I give the same, I will rename the table and give this name product details, food and beverages. If I give the name in a more English-like language, simple, and in business vocabulary, it is easy to understand, right? So technical vocabulary is different, business vocabulary is different. When you work in different business domain, they have their own set of vocabulary. When you work in financial domain, they may use different keywords, definition. As a developer, we may not directly understand them. Similarly, when we prepare our metadata model, table, keys, join, constraint, we use a lot of abbreviation, keyword, complex terms. Business people do not understand this. So we convert the model in exactly the same way which business think about it. That is what one of your very important objective of designing semantic layer. So my personal practice is I've been a practitioner about designing a big large system. So I follow two basic principles: hide the complexity and simplify as much as possible. Don't give a complexity to the user. Hide the complexity and convert the model, data model or business view into business vocabulary. That's two basic principle I follow right from the first day from a business point of view. I also follow one important principle about performance. If it is fast, then only will people are going to use it. So we do a business view. We'll do practical one by one of every activity to have a better understanding of how things work. Right now I'm just trying to plot a one-liner overview of the entire model life cycle. Then you create and manage packages. Packages, as the name indicate, group a collection of objects is your package. You create and manage. So maybe you create different package for different set of users or different needs. I create one package for ad hoc analysis. Package is what you see when you log in first time as a report developer. What you see is your package. Every time I query my data, the information is available to me in terms of packages. You see the listed over here. It may not be meaningful, but the package should be organized in a meaningful manner. So we create multiple package. My personal practice, I prepare multiple packages for different set of user. The first I prepare for testing team, so that I don't want any testing activity should hamper or interrupt my user activity. So I create a separate package for testing team. It may also possible during my UAT test, user acceptance testing, we prepare a separate package. So we follow a lot of project management activities and ensure my product development and testing, incremental testing, product development may go hand to hand. It may be business requirement specific. As I said, you may create one package for ad hoc reporting, you may create another package for management reporting. For internal management reporting, it's an internal reporting. As I say, internal reporting is like you prepare a report as per your comfort, as per your liking, disliking. The another kind of reports are compliance based report. Maybe I'm working in financial domain and I am following a compliance called IFRS, International Financial Reporting Standard. There are so many compliance by different institute or government bodies, like insurance sector follow compliance for Basel II, finance institute follow various compliance. So every business follows certain compliance. There are set of reports in the predefined format. So these are all important things we address these packages through control this. Next is security. For example, I create a separate package for my global HR team and another one is business promotion team. Now the business promotion team have some got very confidential data, including business leads and proposals. So this is very confidential data. I don't want anybody should access this. So what we want, we implement role-based access. People, user from C band, from second level management and C band people can access it. Only some set of user can access it. This is what we control. Global HR, naturally it's very confidential data, including you have got salaries, compensation, benefits. We have information about talent management, hire, and something which may influence the entire organization, like your top people, top management relocation, movement, about that. So all important activities which are very confidential and impact your entire business. It's the backbone of your business, controlled through security. For a technical people, as being a developer or administrator and architect, we may not have, we do not pay much attention about the importance of security, but it may shaken your entire organization. Finally, you publish your package. Once it is published, it is like it is published to the globe and people can access the report on top of this published package across the globe. Once it is published, it is available. It is called content store, content manager. Content manager is like a repository where you can, once you publish, the package would be available to you in your browser for reporting purpose. You can click on the packages and further create report on top of that. So you see, framework manager follow this life cycle. We are going to follow this life cycle exactly in the same fashion. Before we directly jump into designing a framework manager, we should know all the important keywords and definition we use. As the first step says, import metadata. Okay, we are not living in a perfect world, but as far as possible, to ease your life, you try to gather two information, collect to document. The more documental approach you follow, the easier your life is. At least collect to document. First, metadata dictionary. I know many people do not keep it, but it's a Bible for you. Metadata dictionary. Maintain this, which will contain all the important information about what dimension you have, business meaning, dimension, your facts, your keys and joins, everything, you know, whatever you need in order to design your query. This metadata dictionary contains the information. Okay. And then also take up a report mockup. Generally, your architect prepare a report mockup, or it is also called wireframe. Wireframe is nothing sample report. See, if you have an idea what you want to prepare, you can design a solution in a right manner. Okay. In 99%, your business user do not know exactly what they need. They do not know exactly what they need. So report wireframe or mockup give them information about the sample reports. I often prepare plenty of report mockup every time I design my solution. I'll also put this into a shared drive from where you can access all this information. Report mockup like reporting model where you have all piece of information right from, in a broader way, right from the requirement statement, the presentation of data, in which format data to be presented, what is my metadata including dimension, fact, keys, join, source, from where would I pull my metadata. If you follow all the complete approach, the probability of failure or inconsistency of report cannot happen, right? The gaps between your requirement and your design can be reduced to the greater extent. So you collect the dimension, fact information, the source about it, keys, column, join. Then you see, go back to enterprise data warehouse model and check, in order to answer your business query, what dimension, what fact is needed, what kind of join it has, what key it has, what cardinality it has. You answer a couple of questions. Then you look the information business user like to consume. It's a flatten or a hierarchy. In our this example, my information, they like to see top 10 retailer based on the revenue. So retailer information is hierarchical, where people can go down and see the detailed information as they need. So retailer information is organized based on region, country, retailer name and retailer site. Then we have a topology information. Topology information ideally maintained by your infrastructure manager or team, which consists of how many data sources you have, where they are located, what is their IP address, the various information about the underlying topology. So when you connect your reporting system to underlying data source, these all information needed. What is the data says, in case you're using Oracle, what is, in which port it is running, port number, and SID detail or connection details. Then what are the user inputs, how people are going to access information supply. These can be addressed later on. We do not need as of now, but at least the basic information which you need is a metadata, data model, and sample report. These are three baseline, and these three information drive the whole show. You do not just blindly design them. So the step first is import metadata. Before import metadata, ensure you collected all the information. Now, what is a metadata? To query any business data, you need to know what you need to know. Key, you need to know all about database name, database type, table name, table type, table column, column type, keys, join, constraints, all this information we need. Any query when I do, I need all this information. So the required information are available in metadata. So if my user say I need top 5 products for North America. So the query in which format? This is called business metadata. The query is in business metadata. It is required to convert into technical metadata. I cannot submit this query directly into my source system. It is required to convert. So maybe I write a corresponding select query, sum of sales based on region from blah blah blah, and then I write a complete query. Then I think I use rollover function, something like this, depends upon your source. So you need to have information about what is table name, column name, keys, join, column, everything you collected. Under importing metadata, we bring all the information from your data source to your metadata or framework manager, bringing all metadata from data source to your framework manager. Therefore, the framework manager will refer this information to process any query. When you simple process any query, your statement is English like a statement. For example, look at this. I am just going to make a simple business query. See, I should have changed the name of it. However, it's pretty simple. My business model is not very appropriate. I did not use a lot of business terms, but as a user, I would simply drag and drop information without bothering about what is underlying table and queries. Table, keys, and joins are needed. I simply select couple of columns, and behind the screen a query gets generated. So how your Cognos communicating to the data source, what query is being processed, how are the joins. This information you can see in the log file. That's what we are going to see later. So when I process my data, I did not think about what keys, what column, everything taken care by my framework manager. So it's the engine behind your query processing. Your source Cognos has matured a lot over the period of time and tried to align itself according to current business needs and the ever changing your IT needs and your business needs. Okay. In the old days, we used to connect to only set a very predefined set of data sources. Now Cognos support almost all data sources, including RDBMS, or it support any data source which follow ODBC standard. It support RDBMS. It also support multi-dimensional database like Oracle Space. It supports Microsoft SSAS. It also supports semi-structured data sources like your flat file, Excel sheet, and blah blah. In a subsequent release, you may see maybe the plugins are already available, which I am not aware of. Subsequently, Cognos will come up with some way to connect with unstructured data sources, as there is huge demand. Like your Facebook, your LinkedIn, or some social networking site, or some source where information typically coming to a non-RDBMS, not flat file format. That may happen subsequently. So these are list of metadata. Now what are the different keywords we use? This is how we go about it. In case my source is RDBMS, you identify the right metadata. For example, I'm going to design my solution for sales order processing. To make it simple to understand, in our example, we keep only one piece of metadata. As gradually we proceed further, we'll talk about enterprise solution. Right now, let's focus on one departmental solution. When I say departmental, it means we are designing BI for one department, not for enterprise. Therefore, our focus area is confined to one kind of requirement, subject requirement. You see, the couple of dimension of fact I've chosen are primarily talking about my sales order processing, where I have information about different channels, sales channel, and different time the business transaction happen, the promotional detail, product detail, and sales and customer details. I may be adding couple of more tables later on for order. This is sales processing system. Okay, so in this system, I have visualized information about dimension and fact. That would be my starting point. So import object for select object for import. You may have 1000 table, but you like to prepare step by step. Cognos provide an enterprise solution. When I say enterprise BI solution, it means it is not a departmental solution. When I say enterprise BI solution, it means I can use Cognos across all line of business, across all department, across the entire department. Okay. So when I design my enterprise solution, it may possible I am also talking about I'm containing data of a financial, sales, order, HR, procurement, all data I'm maintaining into my system, right? But it should be incremental. You should not directly try to import all metadata and start building it. It's become very complicated and tedious activity. So the methodology which we follow is an incremental update, and this is right practice which one should follow as well. Incremental modification or design, I'll pick up one of the subject and take the required dimension and fact table and design a set of reports, test it, and same we follow for each department or each line of business, right? So select object and import, identify what dimension fact you need in order to answer your question, then import the source into your framework manager. When I say import, all the definition, your table name details, like for example, I import time dimension from my source. My source is Oracle. You see, I queries I go to my time dimension times and look at this table in my source. When I pulled into my framework manager, all the required informations are collected, including column details, all the column keys, joins, all are collected over here. When you look at a sample, test it, you can see over here. So did I close? Anyway, so whatever metadata information you see over here, it comes directly from your source system, including your table, column, keys, join, everything. It directly come from your source system. So these are the column I taken from your source. You can go to properties and further see the type of it and other information. So OBI, your Cognos blindly bring the metadata into the system, step first, and then you follow the steps. Uh, Select your data source, select import object, select criteria to generate report and import. Criteria to generate report, once you select your source, if I write a simple 3-line statement, step 1, bring metadata into framework manager, step second 2, remodel if needed to meet reporting requirement. Remodeling may in turn comes as you can filter your model, filter data model, uh, filter database tables data. Okay. Filtering also require based on business requirement. Maybe I've got multiple tables and I've got some set of data which is no more needed for your BI reporting. For example, I'm working in CRM solution, customer relationship management, and I've got set of table called TBL customer history, right? In this customer history, I have got multiple records, and this is a very old table, and I've got very huge number of records. 500,000 records we have, total records, and we don't want to bring these records into my system, these many total records. But for BI reporting, we need only active records. So I have a column over here called customer last seen, right? I like to bring only those those records where customer last seen is greater than 2010. It means I'm maintaining only 36 months of data. For my analysis, I'm maintaining 3 years of data. So I put some kind of filter. Rather than pull all the metadata, all the records into my system, I'll bring only those records which is meaningful for my BI analysis. So the data come from source may not be absolutely same what we needed for our reporting purpose. You may filter them, you may also apply business logic once you pull your metadata. So you come up with all the logic. It is impossible you have a list of all the filters and business logic in the beginning, but at least you can come up with as much as you have before you design your framework manager. Business logic could be any calculation, could be conditional statement, calculation, simple, complex, which you face in day-to-day life. For example, when you go for a credit card, when you apply for a credit card, what they see, customer buying capacity or customer profile. So maybe if I write technically, it's like this: customer, if customer average customer salary is greater than $100,000, then they're eligible for card type eligibility, credit card type. So eligibility equals to gold card. So some kind of business logic we see every day in day-to-day life, right? It could be simple conditional statement, it could be your calculation. Maybe you like to see top 5 top end product. That could be kind of calculation. More appropriate example like Another simple example, you may like to apply string concatenation. In your CRM, in your source system, they see the information first name and last name. They are two different fields. But when I prepare a report, I like to display concatenate first name, concatenate last name. Simple string function. There are some simple to complex scenario which is required to be addressed to ensure that the report people are going to see should convey the actual business meaning. So remodeling is done if it is needed. Remodeling could be simple, could be complicated as well. You can join multiple fact table, denormalize, normalize structure. We'll take multiple scenarios step by step, talk about this. So what are the different keywords we need to know? I'm going to talk about all these keywords one by one and see how it works. We start with first keyword. So what you should know before starting Framework Manager. Once you install your Cognos, you see a component over here called Framework Manager. Okay. I would be demonstrating everything. I would be demonstrating everything in my existing model, which we would be using as a baseline. We would be using a couple of examples. In one example, we would talk about sales order processing through SH model, which is shipped along with Oracle. So you do not need to bring any additional model. We analyze this. We also analyze one of the other model called Go Sales. Go Sales is one of the very good model for beginners to know everything about business and technology both as well. So we start with SH model. Okay. So what are the important keyword it has? Let's discuss them first, and then we see how to prepare them. So the first step, you're supposed to have a data source. You should know what are your underlying data sources. A data source, as the name indicate, objects. It's an object in Cognos, map to the corresponding object in the data source, and use a modifiable SQL statement to retrieve the data. Now, if I write in a simple statement, if my data source is Oracle, okay, and I have a table called product, data source vendor is Oracle, okay, schema name is data source, my vendor is Oracle, my schema name is sales order processing, my table name is TBL products, right, detail. So what is source? Source consists of everything. What is vendor name, what is schema name, what is table name. Source is TBL product details. Now this is in database context. In Cognos context, this turns out to be object. This is become a Cognos object, right? I show you how it look like. So I have a table over here in my source. I connect to my table and show you the source. So my table is called times or products. Product is a table. See, I describe it, and corresponding there is an object called products. Do you see that? This become database object, this become Cognos object, right? And this is how it look like. The small icon at the top, database icon, a keywords icon is being used, which if you further go down and you can see all the columns are pulled into your Framework Manager exactly same way as it is given in your source. This becomes database object. When I say modifiable SQL statement, it means when you go to edit, right click edit properties, this SQL statement you can modify. Modifiable SQL statement to retrieve the data. The object is identified by a small database icon at the top. The icon specifies type of object, and as you work more, you get used to of these icons. These icons will convey actually certain meaning. Next is your model object. Okay. Model object, I personally try to compare everything with a database object because I'm more familiar with database. I come from database background, you also work as a developer or maybe a fresher, you must have learned Oracle, SQL Server DB to some data source, maybe in your education. So you're quite familiar with the keywords. Model object, I think it should compare with database view. The right context of model object database view. What is database views? View, it's another way of looking at your data. So you can apply, you can hide the complexity of the underlying tables. You can add some business logic in your views. For example, let's prepare the view for, I have a table called TBL product in my current requirement, and in current requirement again I have got very huge amount of data, 500,000 records, but I don't want to bring all the records. I want only those records, like filter my data on product status. There are so many products which are no more active, or I would say not in, other way not in. I don't want to bring those products which are retired or severance, about to retire, to be retired. I don't want to pay attention to this product. So I can write a view, create VW. This is what typically people do in database. Create view. I use a statement VW product active. Only those products which are active. As I write one select statement. Select a star from blah 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 TBL products, where by this statement where product status equals to not in, and your statement, right? So what you create view is database data model object, because in model object, when you design a model object, you can implement these logic, filter condition, calculation. Model object more, you can call this, it does the same purpose what your database view do in your database. It hides the complexity, add business logic, and business and model object as view gets modified automatically. When database gets modified, view does not have its own existence. It completely depends upon table and do not require any additional administration. Similarly, your model can be worked as a view. So I can do exactly the same thing. The methodology which I follow, we discuss in greater detail when I create a business model and all. Business model, on top of technical model, I prepare model object. And when you prepare model object, you can add all the metadata, all the filter, calculation, all. Okay. So you have an option called create query subject. There are three kinds of query subject: model, data source, and stored procedure. I take a snapshot of this. So when I say model, when I say data source, is exactly like your creating table in your relational database context. When you pull data from your underlying database table, manually build query using single data source. Model, build the query based on data that exists in the model. Read this line, the last line. This is, I interpret model as view, because this line draw my attention. Build the query based on the data that already exists in my system, right? Correspondingly, how it is used prudently as per your requirement, that is what we are going to see next. Model view. Next, your query item. Query item is exactly like your column. What is your column in your table? It is exactly like your query item. So just for the sake of testing, I prepared one query subject over here based on model, and I call dim products, and I select couple of column from my product, only required information. I don't want all product category, subcategory, name, and other required data. That's it. And this become my, it's like a view. I pull all the required column from my existing table and prepare my query subject. Okay. And therefore, all column you see under that, these are all columns corresponding to table. These columns are called your query items. Right? Only name gets changed, and each column mapped to your physical table column, directly or indirectly. So query item maps to physical table column directly or indirectly based on certain expression. For example, directly simple means my table name has got a bonus column and which map to my table TBL, products, TBL, sales, and the column name is bonus. One-to-one mapping. Okay. Indirectly means I have one column called commission. Commission doesn't exist. So commission is based on my expression. Sales 5% is commission. So this column is not directly driven. Rather it is based on certain expression. This is indirectly mapping. Directly or indirectly mapping with your query item. Namespace. Namespace, the simplest way to understand, like you prepare folder in your operating system. What is the purpose of creating folder? You prepare a hierarchy of your business data, hierarchy of your information in terms of folder. You basically grouping information by creating folder logically. Namespace does the same thing in a higher way. It's an organizational container. Organization container that uniquely identify the object that it contains. It may possible you cannot have two objects with the same name in same namespace. For example, I have a TBL product twice. It may possible I have two sources. I'm working on data federation where my one data source is Oracle, and I'm also working on another data source is SQL Server. I'm working in such a complicated environment where I put multiple sources. SQL Server is my two server sources. Now both of them have the same table name, TBL product, right? So you cannot have two objects with the same name. I can prepare two namespace. A namespace, first I can see, for the sake of simplicity, I write TBL SRC source SRC Oracle. I create another namespace called SRC Oracle. Namespace I also use personally. The practice which we follow, we also create namespace for logically divide my entire model. You see there are three namespace we have, one for physical layer, one for star schema, one for business model mapping layer. Multiple namespaces, and the same table may exist in multiple namespaces with the same name, provided that they are different namespaces. Otherwise I could not place an object the same name. So we don't have naming conflict. Relationship is something which you are very well familiar with in your tables. When you join one table to another table, that is called relationship. Okay. And the relationship basically derive from your source system. Whatever your source system has a relationship, the same relationship you derive from the source system to your Cognos. Okay. So the baseline is your ER model, okay, in your working transaction system called entity relationship model. Entity mean tables, relationship mean joins. So entity and relationship model, you have ER model. In case you are working in dimensional model, you have dimensional model which talk about dimension facts. But essentially you have joins which talk about the primary key and foreign key relationship between your facts and dimension, or between your dimension parent and child, right? So join specify how two dimension facts and dimension and children are joined together. When you click on this, you have typically same information where you create during join type, primary key, foreign key, join cardinality, and join operator or type. is an equal join. We can also have left outer join, right outer join. This is how. So we also have a cardinality. That's again the fundamental concept of database. For example, simplest example of cardinality is something fundamentally you learn in database concept. When you apply join, we also specify cardinality like 1 to 1, 1 to many, many to 1, like this, many to many, right? What 1 to many? 1 to many, wherever many it is, it's for 1 represent dimension and many represent fact. Okay, so in one simple line, if you see, if you look at over here, one product is sold multiple times in a given day. You sell one product multiple times in a day, right? One product is sold multiple times, so 1 to many cardinality. Or one customer buy multiple products, and each product has got its own unit cost. Or one customer may come multiple times to the same shop. One customer has multiple amounts sold total. So 1 to many retail. In one day, the multiple sales are happen. One promotional activity has 1 to many cardinality between a dimension to fact. That also we'll talk about in greater detail. There's a little difference in your Cognos. You specify join type. It's an equal join, left outer, right outer, or full outer join. Directly, not directly by using cardinality. We've got one nice example in YouTube which decide how cardinality can be, how join type can be controlled through cardinality. Though I'm going to talk about this in next session as well. So if you are not very clear, I would recommend you once again to go back to database fundamentals and once again learn these basic keywords. Scope relationship is completely different thing. I would like to skip this topic as of now, but I'll talk about this in later. Scope relationship is associated with concept called fully additive measures and semi-additive measure, and there's a concept called fully additive and semi-additive measure. What fully additive and semi-additive measure is something which we use in day-to-day life. For example, let's take this is my time dimension, year, quarter, month, right? And my measure is you pay the house rent, right? You pay house rent. So the house rent what you pay is a monthly. So let's say your house rent is 2000 USD. You pay monthly, right? You can calculate your quarterly house rent. So monthly house rent, quarterly multiply 3, 6000 USD you pay. And you can also calculate yearly, 24,000 house rent you pay. It means your house rent is consolidating at every level. You can see your monthly house rent, you can see quarterly, you can see yearly, right? So in simple word, the measure or a fact called house rent getting consolidated at all levels, or getting consolidated or aggregated at all levels. Therefore, it's a fully additive measure, completely adding up at all levels. Right. Next example, we see the same thing. We have got year, quarter, month, but we'll change the measure. The measure is this time, let's say, insurance premium. Insurance premium you don't pay monthly, right? You don't pay monthly insurance premium. Your insurance premium you decide to pay quarterly, right? So you pay $1,000 an insurance premium quarterly, and in a given year you pay 4 insurance premium. For quarter 1, $1,000. For quarter 2, $1,000, like this. You don't pay yearly. So when I look at the insurance premium measure, it is only aggregating at quarterly and yearly. It is not aggregating in monthly. So this measure is semi-additive because it is not aggregating at all level. The semi-additive. If you see your monthly, if you see your insurance premium for given month, you get a misleading information. Again, we'll see this in a live session. So scope relationship is designed to define your given measure is a fully additive measure or semi-additive measure. Okay, next we have a concept called parameter map, which I'll not be able to complete in given time. So I'm going to stop it over here, and we continue discussing about same thing. We continue our discussion in tomorrow's session as well. For now, I'm stopping here.